Hi everybody. So in this video, I'm going to show you how to find the area of a region bounded by the curve and the x-axis when that region is below the x-axis, like we have in this example here. So I showed you in a previous video that to find the area under a curve, where the curve is, let's say, y equals f of x, then it will be the integral between the limits of a and b of f of x with respect to x. And this is perfectly fine in this example, because these f of x values coming from the x-axis to the curve are all positive. All these f of x values are positive along this curve. So we've got a positive f of x and a positive dx. This will give us a positive area. And we know that areas must always be positive. The problem we have in this example is that all the y values are negative. So what we'll have now are all negative f of x values. So when we integrate the function of x with respect to x, we'll get a negative area here, because all of these f of x values are negative. So when we're trying to find the area of a region below the x-axis, we need to take the magnitude of that integral. So this will make any negative area into a positive, okay? So let's try and find the area of this blue region. We want to find the integral between -3 to 3 of f of x, which is a squared minus 9, all integrated with respect to x. And we're going to find the magnitude of this. So we'll integrate the x squared minus 9 in our usual way, and we'll get the x cubed over 3 minus the 9x between the limits of 3 and -3. We'll substitute in this 3, and we'll get the 27 over 3, which is 9, minus 9 lots of 3, so minus 27. And then we'll take away our lower limit, so this will be negative 27 over 3, so negative 9, and then negative 9 lots of negative 3, so plus 27. We'll get negative 18 here, minus the positive 18. We'll take the magnitude of this, and we'll get the magnitude of negative 36, which gives us an area of 36 units squared. Okay, let's try another example. Okay, so in this example, we've been asked to find the area of a region bounded by the curve and the x-axis for this function, and we can see it passes through the origin. So when we integrate between -2 and 0, we know we'll get a positive value. Because this is above the x-axis, all the f of x values are positive. But when we integrate between 0 and 1, we'll get a negative value, because f of x is now negative. So we need to break this up into two integrals. We'll have the integral between -2 to 0 of f of x, which is this area, plus the magnitude of the integral between 0 to 1, because that will make this negative into a positive. So to find f of x, we need to expand out this bracket. We'll begin with these two. We'll get x squared minus x, and then we'll multiply that out by x plus 2. We can collect these two together. So now we can integrate y with respect to x, and I'll substitute this into here and here. So now all we need to do is integrate this with respect to x. When we integrate the x cubed, we get a quarter x to the fourth. When we integrate the x squared, we get a third x cubed. And when we integrate -2x, we get negative x squared between the limits of -2 and 0. We'll use the same idea for this one, between the limits of 0 and 1, and then we'll substitute in these limits. When we substitute in the 0, we get 0. When we substitute in the -2, we get a quarter of 16, a third of -8, and minus the 4. Then we'll substitute in the 1 into this one. We'll get a quarter plus a third minus 1. And again, when we substitute in the 0, we get 0. We know over 4, take away the 4 will make 0. And when you have a negative, negative 8 over 3, this will become positive. Then we'll add this to a magnitude, or a quarter plus a third, take away 1. So this will give us a modulus of negative 5/12. And when you take the modulus of negative 5/12, we get 8/3 plus 5/12. So we get 37 over 12 units squared. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. I'll leave a link in the description below.